Hello everyone. So in this video we're gonna work through some hypothesis testing exercises with Z-scores or Z-tests. So there's going to be five different problems that we're going to work through so that you can see how the steps of a hypothesis testing are used and how to write conclusions in APA style or format. All right, so we'll start with number one. So scores on the GRE quantitative section, the section on math, range from 200 to 800. According to the Educational Testing Service, the mean score for people who take the GRE but do not participate in a training course is population mean mu equal to 555, with a standard deviation of sigma, or population standard deviation of sigma, equal to 139. A training program claims that their graduates score higher on average than the population of graduates who do not participate in a training course. As a budding statistician, you've been hired to test this claim. You randomly select a sample of GRE quantitative scores for n equal to 36 graduates of the program. You get an average score of sample mean m equal to 580 on the exam. Do the graduates who take the training program score higher than the population of graduates who do not participate in a training course? Conduct the appropriate hypothesis test using alpha equal to 0.05 and state your conclusion in terms of this problem. Make sure to use APA style conclusions. All right, so step one is going to be our hypotheses, right? State. So here is step one. Okay. So our hypotheses, I typically like to start with the alternative or the research hypothesis, because in our problem it tells us that we're looking for a mu greater than 555, right? So the training program is basically saying, yep, our graduates score higher. So the research hypothesis is mu greater than 555. And so that leaves a null hypothesis of mu less than or equal to 555. So you can see that this is the full range, right? And this is how it's set up in symbols. So let's go ahead and move this up. In words, the null hypothesis is stated this way. Graduates who take the training course do not score higher on the GRE quantitative exam. And then the research or alternative hypothesis is stated as graduates who take the training course score higher on the GRE quantitative exam. All right. And what you'll notice is that I pull out all of the information out of the problem. So population mean is equal to 555. Population standard deviation is equal to 139. N is equal to 36. Sample mean is equal to 580. And alpha is equal to 0.05. Okay. So let's go ahead. Scroll up just a little bit. Let's go ahead and here we go. So my first step, and remember that our Z test is going to be sample mean. This is the formula right here. The Z test is equal to sample mean minus population mean divided by standard error. Now, my suggestion is to always do the standard error first so that you don't have a fraction in the denominator, right? So here's standard error. Sigma m, which is equal to population standard deviation divided by the square root of n. Okay? So all we need to do is just plug in our numbers, right? So it's 139 divided by the square root of 36, which gives us 139 divided by 6, which gives us a standard error of 23.1667. Notice how I round up. I round to 4 decimal places, because it's just it'll give you more accurate numbers at the end. Okay, so now that we have standard error, now we can go ahead and do the z-test, right? So our sample mean is 580 minus our population mean of 555 divided by our standard error of 23.1667. That gives us 25 divided by 23.1667, which gives us a z statistic of 1.079, which is approximately 1.08. I round up to the hundredths because remember, in our table in Appendix B, the z-scores are provided to us in the hundredths, right? To the hundredths. So with that said, let's pop over to the table. Actually, before we pop over to the table, let's draw this out real quick so that we know which column we're going to be looking for, right? And actually, you should do this before you start doing the calculations. So mu is 555, right? And 580 is probably somewhere over here. And we're saying, oh, you know what? The score is supposed to be somewhere to the right of that, right? So it's greater than. We're expecting graduates to score higher, right? So let's go ahead and pop over now to the actual table. So here is the unit normal table. And what you'll notice, we've gone over this a little bit, right? So column A, I think in words, but we didn't really take a look at the actual table. So column A is your Z, column B is the proportion in the body, column C is the proportion in the tail, and column D is the proportion between mean and Z. Right? So we're interested in column Z, the proportion in the tail, and we need to look for the Z of 1.08. So let's go ahead and scroll over to, yep, there it is. So 1.08 is right here, right? And our probability is, in the tail, is 0.1401. Okay, does everyone see that? 1.08 is the Z statistic in column C in the tail, which gives us the probability or the area in the tail of 0.1401. So our probability is 0.1401. This probability is actually greater than alpha equal to 0.05. So our decision, right, the decision, step 4, to make the decision, we fail to reject the null hypothesis. We're not going to need to calculate an effect size because there is no effect or no difference, right? So the way that you would write this out, the conclusion, as an APA style conclusion, we would say fail to reject H0 or the null hypothesis. There is not sufficient evidence to conclude that the graduates who take the training program score significantly higher on the GRE quantitative exam, comma, Z, open parentheses, n equal to 36, close parentheses, which is equal to 1.08, comma, p equal to 0.1401, period. Individuals who take the training course do not score higher on the GRE quantitative exam than individuals who do not take the course. So what you'll notice is that the first sentence is the statistical evidence, right? So we say there's not sufficient evidence, right, that the graduates who took the training program scored significantly higher, but you have to provide the actual statistics after that statement in order to back up your claim, right? And then once you've provided the statistics, then you can say in English what it is that you tried to say in statistical terms. All right, so that's our first problem.